Well, good afternoon, everyone, or good morning, wherever you are. We're delighted to welcome you to this third session in our series of weekly seminars about innovation in manufacturing and supply chains in Asia. We're very happy that even though we have to have an online meeting today, we have Dr. Kwang-Seong Choi, who is joining us from not KAIST, ETRI, the Electronics and Telecommunication Research Institute in Daejeon in South Korea. And Dr. Choi is a PhD from KAIST in Daejeon. Since 1995, he's been an expert in semiconductor packaging technologies. He worked for Hynix Semiconductor and was developing chip scale packages, which are packages that are not any bigger than the chips that they're packaged in. Without a package, the chip cannot connect to the system. So it's critical to look at packaging as an area of advanced technology that has been progressing a lot over the years. Dr. Choi joined ETRI in 2001. He is now a director and research fellow at ETRI, again, the Electronics and Telecommunication Research Institute. He's looking at packaging materials and processes for three-dimensional chips, stacked computer chips. And he has been a director of a major national project in South Korea, the Semiconductor Advanced Packaging Leading Core Technology Development Project, which is sponsored by the Ministry of Industry, Economy, and Trade in South Korea. So we're delighted that Dr. Choi can join us this afternoon, and we'll ask him to give some prepared comments. Feel free to write questions in the chat window. After Dr. Choi finishes his comments, I may ask a question or two to get discussion started. And then if you do have a question, either put it in chat or use the raise hand function on your Zoom screen. So Dr. Choi, welcome. Thank you very much for joining us this morning for you.
Thank you. Hi there. So I'm Kwang-Seong Choi from ETRI in Korea. And it's my honor and my pleasure to present my technology and my thought about the technical innovation and the supply chain and ecosystem. So I will share my slide. So the topic of my presentation is innovating semiconductor and micro LED supply chain. So the Korea is famous for semiconductor and micro LED. I mean the OLED or LCD, the display industry. So, but today the main idea is innovation. So I talk about the semiconductor and the micro LED from the point of technical innovation. So this slide show my presentation roadmap. First, I'll introduce the Korea and ETRI. I think that all of you may know well about Korea, but I want to emphasize from a different side. And I want to share how the background of the innovative technology for semiconductor and micro LED industry. And next, we prepared for a long time to develop the technical innovation for semiconductor and micro LED. I will introduce that to you. And next thing is the main idea, how we can achieve the technically innovative idea can be implemented in real world. I mean the mass production, supply chain, and ecosystem. And finally, I will summarize my presentation. So I think all of you, where I am. This is the Korea, South Korea Peninsula, and this is America. So I'm in Daejeon. It takes about 2 hours by by car. So I think that all of you, they already enjoy K-pop, K-drama, and K-food. So please raise your hands. How many of you have visited Korea? Or yeah. Oh, thank you so much. So I don't feel talk about the Korean, the recent, the famous sensation, but I want to emphasize one thing. This is kimbap, made by my friend for me and my wife the next yesterday, and I think that some of you already tasted. So I think that these are the related with the innovation, innovation in culture. So K-pop, K-drama, K-food, all of you, most of you that like that because it's the innovation in culture. So but one more thing I emphasize that today is the Hangul Day, Hangul 날. So Hangul is the Korean alphabet. So it is designed by King Sejong the Great in 1443. So quite long ago. And I think that this Korean character is the only one designed by a specific person, a very genius king. So let me see the benefit of Korean alphabet. So Stanford University. So I can write down the Stanford University in Korean alphabet. 스, 텐, 포, 드, 대, 학교. You know? You know the difference? You know the advantage of our character? One more. 스, 텐, 포, 드, 대, 학교. So the consonant and vowel, a letter is consist of consonant and vowel. You can present the one syllable as a one letter. This is a big the advantage of our letter, our character, Hangul, and it is very good for AI era, semiconductor era. Okay, let me introduce our institute. So as I said, I'm Daejeon, and our mission is to develop technology. And once we develop a good for industry and we want to transfer to commercial area, and also we are make the strategic planning for national R&D policy, and we also involved in make standard for international. This is these are our the proud. I'm proud of that. The major achievement. First, the DRAM we made with the Hynix and the Samsung to develop the DRAM quite long ago, and we also developed CDMA with Qualcomm. So at that time, Qualcomm is a startup. So now is a big company. So we are the made a foundation, and we also developed the display OLED and AMOLED. I'm also working on the micro LED for display, and the total number of our employees over 2,000, and the R&D budget of this year is over $500 million. The one thing that I emphasize is that royalty percent. So the royalty percent are close to over the 10%. I think this is the quite high number among the industry. especially for the all over the world. So my next topic is that the background situation of the semiconductor and micro LED and how we can make the innovative technology can be implemented in the real world. So you know the ESG management very well. Especially I want to emphasize the environment. So environment side, the major point is that climate change strategy. So I heard you are suffering from the typhoon, and we Korea also the suffering the high temperature and flood. So that was not experienced before. So that leads to we need to save the water and energy. So we should maintain the carbon as low as possible. But I have some one question. Do you heard or see or talk about the specific example of ESG management in a dramatic way? So I think that this is the I guess that you might not the a innovative idea to achieve the ESG management in real world. So that's the reason why I'm here the to think about that. That means that I have real the example and I want to make them to be used in real industry. So I made some guideline for semiconductor and display industry to achieve the low carbon era. So the first thing is that we should reduce the number of process that lead to the equipment, the number of equipment size reduced, and that can lead to power consumption reduction and other things. And another thing is that I want to lower the process temperature or processing time. So you know that this advantage can be explained that I explained already. And that leads to the clean maintenance power. You know, the clean maintenance needs lots of power, electric power, and lots of the clean the water for the cool down. So we should reduce the cleaning maintenance power. I mean the cleaning size or more specific or the accurately the reducing the equipment area. That is related to the first thing that I explained. And next thing is that reducing byproduct harmful to the environment. And the final one is that the reduce consumable subsidiary materials such as nitrogen and so on. So if you think about that after my presentation, hey, Kwang-Seong, you should include one more thing or something other. Please let me know. So I want to make the list perfect for the ESG management. And my next the background want to talk about is that CHIPS Act in USA and the Korea. So that this is the related with the political or the international the situation. So as you know, the USA uh, can produce memory and you are very strong on software and equipment. But as far as I know, the CHIPS Act in USA is to achieve this all of the supply chain to produce semiconductor in USA territory. I mean USA mainland. because you know the semiconductor is not a just product, but the national security asset. So you know the every country want to make the semiconductor supply system in their own territory. So, but the the table that I showed is the just number and talk about the real things. So these are the AI accelerator designed by the NVIDIA. So let me check the availability in USA. So GPU designed by NVIDIA, fabricated by the TSMC, Taiwan, and the HBM is fabricated by SK Hynix and Samsung in Korea. And silicon interposer made by in Taiwan, and the substrate is made by made in the Japan, and all of them assembled in Taiwan. So you know the real situation. So the politician in USA thought, oh, it is the great problem, a serious problem. So they think the USA can make this kind of the advanced the semiconductor product in USA. And I want to talk about the Korean CHIPS Act. So we Korean want to the make supply chain for such the AI accelerator also, but the USA, Taiwan, Japan, even China give the industry the subsidy, but Korean government do not want to give the direct the budget. Rather than our government want the tax break for investment in semiconductor industry. So you can read the detailed number, but the effect of this kind of tax break is important. So if the tax reduction rate is increased by just 1% point, South Korea top 10 chip makers would save up to $277 million. So that make in that way that makes sense. And our government want to establish a semiconductor specialized complex. So the Yongin Pyeongtaek for fab, the fabrication plant, and the Gumi located here is for the material and the component and equipment manufacturer. And Ansong is the industrial zone for the another equipment business. So you know that we are already the very famous for memory production. So we already supply chain about that in our own territory. So we need just lead them to develop high level, I mean the advanced level, the semiconductor. And we have the two giant. So one is the Samsung Electronics, and another one is SK Hynix. So they announced to invest lots of money to build for Samsung case 6 new fab in Yongin, and for Hynix case they want build 4 new fab and in their and they invest lots of money. And so using this kind of the investment and tax cut, our government want to take up at least 10% of global market of non-memory chips, because as I said already, we are governing. We are already the grab the memory chip area. So we want to expand the market to non-memory chips. And we also Korea also started the R&D project to promote to develop the innovative technology for semiconductor and semiconductor packaging. And especially I'm a special guy in the advanced packaging area. So I involved in this national level the project, and its project the budget is about the 200 to 300 billion dollars, and the period is about 7 years. So we just passed the screening the process. The budget it cut into half, but fortunately I think that the cut budget is the cut down in half, but I think this is big deal, big chance for us. So until now I will talk about the CHIPS Act, but the more important thing to me is that every country, not every country, the semiconductor country, I mean the USA, China, Taiwan, and Japan, Korea, they want to build their own semiconductor ecosystem. But I think they cannot do that without any others' help, any others' assistance, because semiconductor needs lots of the budget and people and experience, and so we need to collaborate. So, this is my personal point of view. I think that because of that, you are more strongly rely on the collaboration between them. So until now, we are just the focus their own the strong point. But now we need to develop all area of the semiconductor supply chain, equipment, material, component, assembly, and semiconductor. So that can be done without the other nations, the strong point. So that I think that it is great chance. The great market will be open if I can develop a very the distinguished idea. So let me explain another topic. So the technical issue to be resolved. I mean that we are still the research about that in R&D area and as well as the industry area. This is the cross-sectional image that I already explained to you, and we call this is chiplet interconnect. Chiplet interconnect, the interconnection between the process or the memory with the substrate, advanced substrates, silicon substrate. And to achieve that, the industrial people using the flip chip bonding process, and they are confined to this area below to 40 micrometer. So we need to, this axis is the interconnection pitch. Pitch mean is the distance between the interconnect. So the industrial people have solution, the up to 40 micrometer. So we need to develop the technology for covering the lower than 40 micrometer. So every the semiconductor company and even including ETRI, so the want to develop the area technology for this area. So this is the technical issue to be resolved. And how about micro LED? I think that you might not know about that, but so I want to explain in real things. So this is micro LED. So its size is micro level. So you know why its name is micro LED. And the micro LED is fabricate wafer level, but wafer level only monotonous color can be fabricated red, green, blue. So these three semiconductor should be the transfer from wafer to display panel. So this is the developed by our own technology. But the current micro LED display problem is it costs so high. Its cost more its price is more than the $100,000. So the the normal people cannot be cannot afford such a the high cost, the high price, the display. But it is very the its advantage very clear, high reliable, and you can see even the day under the bright sun, and it's the resolution is quite high. So this this kind of display can be applied to display signage, the smartphone, and even the micro display for AR and VR. But the problem is the cost. So as I said earlier, the micro LED is fabricated on wafer, and it should be transferred to display panel. But the number of micro LED to be transferred so high, so the everybody in display area want to reduce cost down by 20, but 20 times, but it is very difficult because the transfer and assembly process it costs very high. So we need to find a innovative solution to reduce the cost. So until
So,
now, I will.
Dr. Choi, can I interrupt? Can I interrupt with a quick question
Yes,
about the micro LED? So it is a very expensive new technology that would essentially replace OLED kind of display technology.
if the cost down,
Is
you can reduce the
yeah,
cost
to
down.
get the cost down. What is the
Yes,
advantage of the micro LED? Is it much less power consumption or broader range of color, or what does it do?
all of them, all of you talk about
Okay.
the brighter, high reliable, endurable more than OLED. OLED is made from organic. Organic tends to deteriorate with aging and time. And because micro LED is a semiconductor, semiconductor is quite reliable and
Yeah.
everlasting. And it is bright. So you can see the signage on the street. The, even on daytime, the bright under the sun, you can see clearly the display image based on this LED, the signage.
Okay.
Okay.
So the brightness makes good sense. But the
Yes.
process of making it would be to take the chips
Right. Right.
and transfer them to the display substrate. So if the
Mhm.
average chip, the die size is what, 25 millimeters or something like that, or
Yes.
is it?
People want to reduce the size of micro LED because you can make more the LED
Uh-huh.
device. So the even less than the 10 micrometer, 3 or
Okay.
even the nanometer level can be the very good in terms of the cost reduction because it is made of on the wafer level. So if you reduce the LED size, that means you can make more LED in just the process, the same process, you can make more the number of micro LED. So that is the reason why people reduce the LED size.
Okay. Yeah. And when you're talking about size, you're talking about the size of the features on the chip, the LED. Um, I was thinking about the process of taking tens of thousands of these chips and putting them onto a meter sized display.
So let me explain about the technical innovation. The innovation is based on the laser seed bonding. I will skip the detailed description, but I want to share the process step. Please focus on this area. So laser is the attack, the device area, the not a point, but the uniform area. And you can expand the process area as large as possible. And the technical innovation is the materials for LAB process. So it takes almost 20 years. So we spend about the $45 million to develop this kind of technology. And then you might question, what is the innovation? So let me explain using the video about conventional the process and material. So these are the flux material and these are solder. You see the solder material melt down. And another thing is that you can see the vapor, the 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 pore are arising. So this is caused by the vaporized component in the flux area. And another important thing is that the process time, it lasts to the, the over 3 or 5 minutes. I think in first part of my presentation, I already explained the ESG guideline. It's better you can reduce the time, process time, and it's better you can reduce the temperature. So the major point is that the laser irradiation time is almost 1 second. So we can reduce the process time from 5 seconds, 5 minutes or 3 minutes to just 1 second. So that is quite the innovative idea. And another is thing that the vaporized component is shown here. So the vaporized component contaminate the equipment and contaminate the product that we use produce, and this material act as an acid, and they corrode the component that we should the produce. So you should clean using the water. That means you should consume lots of water. But using our material technology, there is no hume, and there is no the cleaning the process. So you can reduce the process step, and you can reduce the substance harmful to environment. So that I think that using the technology, I can. So or some of the industry guy can meet the guideline of the ESG management. And recently, and the next, uh, the 1 month ago, I mean the September this year, so we transfer this technology to Korean the material company. So I mean that we have the material, the part for commercialization, And next, I think the next year, hopefully, I can transfer to this technology to equipment manufacturer. So material, equipment, and finally component, and then system. Then I think that I can make the supply chain based on our innovative technology. So this is the just example, one example, how our technology can be applied in real world. This is for the semiconductor, and that I explained about it, and especially for chiplet bonding. I'm not intended to technically the detail about this, so but just talk about the result of our technology. So there is the emerging technology area covering the chiplet interconnection, the below 40 micrometer. So this pitch of this the chiplet interconnection is about the 20 micrometer. So actually, we achieved the chiplet the interconnection uh, about the 4 micrometer, just 4 micrometer. So that we already achieve this kind of new technology for the emerging technology. And we already present this data on the ECTC conference. That is one of famous the 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 packaging conference held in the USA. And another thing is for the micro LED. So why the micro LED cost so high? Because there are lots of number of the micro LED to be transferred, bonding, and repaired. So usually people think about that. Hey, you should transfer first from wafer to panel and bonding, and you should repair. So, but when I got the news, the technology about micro LED, I think about that way lead to the capital expenditure, because you should invest lots of money to make the lots of the equipment, because the throughput of each transfer machine is so low. So and there are lots of the I mean the auto optical inspection system. And so one more important thing is that if you added lots of machine for just one process, that leads to yield down. So if you reduce the code, the process step, I mean the reduce the equipment, then you can enjoy the high throughput and high yield. So based on our new technology, we developed a simultaneous transfer and bonding technology. We call it SciTrap. And using our technology, we can reduce such a lot of machine into just one equipment. And we also find a way to reduce the repair process. By that way, we can reduce the process step, we can reduce the process time, and we can reduce the clean room, the area, and also we can reduce the byproduct and the generating substance harmful to environment. So I think that this is a very specific example, real example to achieve the ESG management. So next thing is that it is the main main theme of this series seminar. You have a very the innovative idea. Then how to make it implemented in real world. So we need to find a way. Then you need the discover what is the real nature, intrinsic nature of the industry. So our Korea is famous for the mass production for semiconductor and display. And so I have met lots of the management people, engineering people, and have concluded like that. So semiconductor is for the mass production, so they need the large scale investment. And also the customer is cannot, you cannot image their the usage environment is very different, depend on the people. So its reliability level is so high. That means the industry is so conversive. They do not like the innovative idea because you should investment time and money to the validate. So the if you spend your the energy for a specific time, that means you may lose your time, or you may remain behind your competitor. So the it is quite the contrary, because they are using the develop their technology uh, the based on the innovative idea, innovative the technology, but in real world they are so conservative. So at first time after develop my technology, I have some difficult to make the persuade them to try our technology. But fortunately, I have some the very big policy change and the technological change. That is the ESG management and CHIPS Act in USA, in Korea, Asia, and technical issue to be resolved. So let me explain by using the real things. So this is the stack package used for smartphone. I think your smartphone has component like that, application, process, and the memory over AP. So to develop this kind of technology, the 3D interconnection should be located here. To make the 3D interconnection, the here AP package, the conventional process is composed of dissimilar electrolysis plating and electroplating. This kind of process make high volume of hazardous substance and high power consumption and lots of consumption of clean water. And the line is so big, so you need to invest large capital expenditure. But fortunately, I met some the company that's named Protec. They want develop dry process rather than wet process. They made copper post, and they need our material, bonding material. So using this our material and laser sheet bonding, we can make this copper post for 3D interconnection. So using this kind of process, there is no way to produce hazardous substance, lots of power consumption, lots of capital expenditure. So you can make ecosystem for ESG management, and you can make your product with a very lower cost than conventional way. So this kind of technology is a good for, especially for the designing their plant because they can reduce their equipment, the plant size, so they can make money. And the environment, the issue is more the importance of environment is now more focused. So the people need tend to like this kind of technology. So another thing is that I think that the working it the Korean company is not enough. I should work with the overseas startup such as Silicon Valley or the Grenoble area. There are the many startup the group to develop their own the ecosystem in their nature. So about 3 years ago, I met Avicenna in the Silicon Valley. They want to develop the interconnection, optical interconnection between uh, the GPU, the AI accelerator, and the HBM. So currently, the interconnection between the GPU and HBM based on copper wire. But in the roadmap among the AI the engine manufacturer, they tend to increase the number of HBM and increase the performance of GPU. So the conventional copper wire cannot afford that because the lots of the HBM, number of HBM is necessary. So the Avicenna make system like that. So one of the innovative idea using micro LED for the optical communication. So here is GPU and the optical the component made of the micro LED and the PD array, and they make connection between these optical component with fiber bundle. This is another their idea. So you might question how ETRI's innovative technology can be used in this kind of the technology. So as I already explained, we are specialized on transfer and bonding, simultaneous transfer and bonding of micro LED. So the Avicenna people found out our technology can be used for implement the make interconnection between micro LED and the silicon backplane. So using this kind of the innovative idea and make their idea in real, I think we can make the ecosystem for new ecosystem, the Korea and USA simultaneously. As I already explained to you, so in every part of ecosystem for semiconductor and display area, I expect more collaboration, more collaborative work should be done because we cannot develop our single technology without any other's help, without any other's idea, because we people, the people are strong when we get together. So let me summarize my presentation. Korea is a country of innovation. So the next page is some my the idea and my the thinking, and I want to realize in real world. At the center of this innovation is ETRI. ETRI has a strong track record in building ecosystem. And as I said earlier, to make the innovative idea implemented in real world, you should find out the intrinsic nature of the industry. I think we have good chance. ESG management, CHIPS Act, and technical challenge faced by the semiconductor and display industry. And I explained that I spent almost 20 years to develop such a technology. That means Korea has established a robust R&D support system. Using that R&D support system, I can develop such the distinguished technology for semiconductor and display sector. And after developing such a technology, I want to make them used in mass production and implemented in ecosystem in ETRI, USA, even France. And I think that this is by to achieve such a purpose, working with startup, the Silicon Valley startup, Grenoble startup. I already make connection between them, and I want to expand more partnership over that area. So using such the R&D ecosystem, startup ecosystem, I think I can the implement, I can achieve the ETRI vision and my vision also at the same time. Thank you for your attention.
Thanks very much, Kwang-Seong. That's a really interesting presentation about a lot of technology developments. Some things like developing optical interconnects have been things that people have been working on for years. And it's fascinating to see that we're coming toward something that might be a practical solution. I have a couple of sort of general questions that I'd like to ask. Then I would like to open the floor to some audience questions. Um, so in terms of ESG management, you're trying to reduce the use of water, you're trying to reduce energy use, you're trying to reduce the harmful chemicals that get out as a result of the process. Uh, Also, you're trying to reduce the price, which is not ESG management, but very much has to do with the efficiency of the processes and the effectiveness of the processes. Um, are you seeing much concern about rare earth metals? The
Sure.
sources of materials that may not be accessible outside kind of areas that we don't have very good relations with right now.
That's a key point. So the one of the material that used in our technology, especially for micro LED, indium. Indium
Yeah,
is
Indium.
cannot
Yeah,
yes, indium. Indium cannot be available in Korea. I think the China is major the produce pro,
yeah,
manufacturing nature the country. So the for the a specific material we cannot we cannot even
yeah.
survive without them. So that is one of critical. So
So, yeah, kind of related to that, things like the CHIPS Act, and the U.S. has its CHIPS Act. I guess Korea has your CHIPS Act as well. Do you think that things like the CHIPS Act are making international cooperation more difficult, or is there a way that it's becoming easier?
more easier. It is quite contrary to the common sense, but I think that it is more
Uh-huh.
easier because
Okay.
I think that the to make the semiconductor in a very short time with a large of money is very difficult. You should have problem like the yield problem and the cost problem and turnaround time problem because semiconductor needs lots of experienced people and the high level equipment material and you should train the engineer people for such a long time. So the USA coverage over the foundry less than 10 nanometer. There is
Right.
0%.
None.
So
Yeah.
yeah, USA already the input invest lots of money to make the 10 nanometer, less than 10 nanometer, the foundry, but the result is not so good. That means to achieve their own, the only one single ecosystem, single supply chain for advanced semiconductor can be uh, cannot be easily achieved. You should help from your neighbor. You should the require. You need assistance from your friend.
Yeah.
And the one more important thing, you don't have the substrate. So substrate is a key component, but this substrate is not here. Is not here. So USA until now cannot make the substrate itself by on your own. So Japanese people, Korean people, I mean Japanese supply chain and Korean supply chain, you need to develop this kind of the supply chain for the high-end substrate. By this is just a single example. There are many things, many substance we should cooperate each other. So after CHIPS Act, I think the collaboration work between the USA, Japan, Korea, Taiwan will be the much more than is expected at this time.
Okay. Thank you. That's a the answer I was kind of hoping for, frankly. I'm curious, in the US, if you go back to that slide that showed percentage of the different components of chips and who has this slide, yeah. Notice that the US has such a dominance in design software, and
Yes.
the US has developed an entire fabless semiconductor industry where chip companies really just come up with designs for the chips, and the chips are fabricated elsewhere.
Mm.
Um, it's interesting to me that Korea still maintains 25% of the foundry business in the world, as well as which is contract manufacturing for other companies' chips, and also making, almost half of all the memory chips in the world. One of the kind of beliefs in the US is that as wage levels increased,
Uh-huh.
it
Yeah,
became
sure.
very difficult for the
Mhm.
American manufacturing industry to compete with, quote, cheaper manufacturers in Taiwan and in other places. But yet, wages have gone up a lot in Korea in the last 30 years.
Mhm.
How has Korea managed to keep its kind of manufacturing base as well as, its dominance in memory, uh, despite the increase in wages?
Mhm. Yes, yes. The increase rate of wage, the Korean the experienced engineer is quite increase, but still much lower than USA engineering.
Okay.
It is the wage level is comparable to the Taiwan engineer. So I think that the that kind of that wage difference make the effect on the product semiconductor product cost. So the Morris Chang, the founder of the TSMC, said in public, the making semiconductor in USA may not succeed in because of the higher level wage. So the cost of the competition of the US made by the in US is not sure. We cannot, he cannot make sure about that. So I think that this is political reason. So it's a kind of war, semiconductor war. So I
Right.
don't know what is the result of this kind of conflict. But one thing, important thing is that collaboration and make new ecosystem in USA, Taiwan, Korea, Japan, even China is the more the bigger than
And I
before.
hope you're right. I really hope that the new mood will be for closer
Mhm,
collaboration.
mhm.
Um, how did COVID affect the situation with the chip industry in Korea? Um,
Pardon?
we had, COVID, the COVID pandemic, COVID-19,
Hmm.
where there was so much disruption in shipments. And when you had such an international supply chain for the chip industry, um, that it was quite a bit of concern in the U.S. and it was one of the things that led to the CHIPS Act.
Hmm.
So I'm curious how it looked in Korea if you would not be able to complete the assembly process of the final product, no matter whether you had the chips or not, right?
Hmm.
Um, what, how did COVID affect the kind of development, technology development side in Korea? Can you tell any special impact?
Yes, I'm an R&D people, R&D person, and I
Yeah.
also the worked for the Hynix Semiconductor for a while. So I think the COVID a kind of the blessing for us because the ecosystem is broke down, current ecosystem. But current ecosystem, as you can see, the wafer and material and even the equipment, we are heavily rely on the overseas. But COVID means the insulation. We cannot the freely trade with our neighbor, with our friend. So
Yeah.
that means we need to the establish ecosystem, material, equipment, key component in our side, our own. So the I'm an R&D engineer to make the the develop technology for industry. So we all of the R&D engineer was very happy because we have a chance. Actually, we have been looking for such the chance to make our developed technology to be implemented in Samsung or Hynix or in the supply chain. But everybody in industry said have no time, and we are this is top secret. Your R&D people, the research engineer from research institute cannot be involved in this kind of top secret technology because of security reason. COVID make us to involve some the key project and even government the the they want to make our own ecosystem because the semiconductor and display the technology is national security asset. So people in government area want to the make the key industry, key supply chain in our own mainland. So the COVID is coincide with that situation. So I think that COVID was a blessing.
Okay. Um, it's good to find a silver lining around the cloud. Um, I'd like to ask you to go to page 17 in your presentation. This is the laser assisted bonding. this is a technology that's ETRI is now commercial. I'm sorry, I'm looking at the wrong one. It was 17 in mind. The introduction to ETRI's innovations about the development case with laser assisted bonding.
Actually, the lasers,
Okay, that's good. Yeah.
laser
The
assisted
reason I asked,
bonding, uh, laser assisted
my
bonding
question,
is, yeah,
I'm sorry, my question
yeah.
for you is for people who would be interested in the technology. I understand that you will be visiting the US in a few weeks, but in regard to the commercialization process, is there a good contact that people who are in the technology world could have in order to find out more about this technology or other technologies that might that you've mentioned today?
So okay, let me explain more about things. This LAB process is introduced by commercial, by industry first, and then the very same time the realized this kind of technology can be used for our material technology, so that they are compatible very well. And I think that I should expand this kind of the technology. I should make contact in USA, global
Uh-huh.
area. Yeah. So the first I was whenever I visited the Silicon Valley area, to attend the international conference for display or semiconductor, I tend to announce and promote our technology using our my personal network. And the second thing is that I plan to establish the ETRI mini lab, hopefully next year, so we can make a platform where we can work with the many startup in Silicon Valley. So actually, I will visit the Silicon Valley in November, and at that time, I will meet the Richard, and I'll meet the Avicina that I explained earlier,
Right.
and try to find out how I can establish a 3 mini lab. So the under the lab, I think in the lab, I think that I can have installed the machine, our machine and our material, so we can collaborate with the Silicon Valley startup. So by that way, I can make contact point, and just not just the contact point, but the in real place, real the laboratory. So the interested people can visit there and see how it works and how we can work together.
That's a very exciting kind of plan. For everybody who's on the Zoom meeting now, let me suggest that if you're interested in some of these technologies and would like to have further discussions, send me an email and I will forward your mail to Dr. Choi. And, depending on how the timing works out, uh, arrange a direct meeting to discuss the commercialization of some of these technologies because it is a great kind of opportunity to work together toward these things that are not just making more expensive chips or more high performance chips, but improving the process for ESG, making sure that we address the kind of national security and independence issues, and really also keeping up with the technology. Your slide that showed the pitch of the different packages is something I'd like to just comment on briefly, where the chips feature size is getting down into the single digit nanometers. And yet, the interconnects where the chip is connected to the rest of the system, um, we're talking about microns, micrometer size distances between the different um, input-output um, pillars or whatever you want to call them. It used to be solder balls, but now there are all sorts of techniques that are not really the same as solder. Um, I think that it's fascinating that the whole chip industry seems to be focused so much on moving to 7 nanometers, or even in Japan, they're trying to make a 2 nanometer chip.
Mhm.
And yet you can't have a die with a 2 nanometer feature size unless you can package it in something where you can take advantage of the density of the chip. Um, this is an area where packaging has tended to be ignored in the advanced research community in a lot of places in the US. There are a few really advanced packaging research groups in the US. I think Georgia Tech is still quite strong. And, you know, Dr. Choi, you've mentioned Grenoble a number of times. So the French national laboratories are there, CNRS, and they're very active in moving forward with these areas. Both Dr. Choi and I will be in a meeting in Hsinchu, Taiwan next month. So that's along with people from Grenoble. So it's an exciting area. We've got time for maybe one or two questions. Anybody in the audience like to ask a question, please use the raise hand function on your Zoom. Jermaine, I think the floor is yours. You may be muted. You're still muted.
Good afternoon, Richard. How
Right.
are you?
Thank you.
Calling.
I'm fine. Thanks.
I have a quick question for Dr. Kwang. The availability of semiconductor equipment. We have a small startup that we work to locate existing equipment. We refurbish and re-engineer some of the old Lam equipment. Is there a constraint of the supply of Lam equipment around the world, in your opinion? You are the subject matter expert.
So I'm not locate expert. So, but in terms of locate, as far as I know that the electrical property is important, but more important thing is that mechanical reliability. So that you know that I introduced LAB, laser assisted bonding, and especially the smartphone AP, the 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 semiconductor design company adopt the laser assisted bonding for locate reliability. So advanced locate uh, has some the drawback. So I mean
Mhm.
the losing point regarding the mechanical reliability. Even the assembly process or the reliability test, they tend to fail because of
Mhm.
the very fragile. So I think that you should focus on that how to increase the mechanical reliability.
Thank you.
That
Thanks. I think that's good. Thank you very much, Jermaine. Maybe
Thank you.
time for one more question. If not, I want to thank you again, Dr. Choi. It's been a great presentation, a lot to think about. It's good to see that technology development is trying to address these issues, not just make more money, but to address the ESG issues and the kind of resource availability issues that we talked about today. And I look forward to seeing you in person in a couple of weeks.
Mm.
Thanks, everyone. Quick reminder, we do not have a seminar on October 15th. That will be an off week. We resume our seminars on October 22nd with Professor Paul Raj talking about how India is moving to establish a semiconductor manufacturing industry, more or less from scratch. So we will talk more about these issues in a couple of weeks. Thanks, everyone. We'll call it into the session today. Thank you,
Okay.
Dr. Choi.
Thank you.